All right, let's talk about angles in geometry. So first of all, let's review a couple definitions. So, we have our line segment here that stops at those 2 points. We have a ray, and we have a line. So we got our line segment. We have our ray, and we have a line. Okay? Great. So let's talk about the definition of an angle then. So an angle, more generally, is composed of two rays or something more complex. But it's always like two rays, two line segments, or something like that meeting. And the angle is at a similar point or vertex. So let's say we have a point P right here, an array coming off like that, an array coming off like that. This is point P. The vertex is P, or you could call it the similar point. So let's say we do something a little more complex. We have two rays, AB and BC. The point that they have in common is B. So that's going to be our vertex. And then let's just say we have A here and C here. Okay. So that is our similar point. And how do we name the angle? So it's angle ABC. Or you could call it angle B. Now, they're probably looking for something like this with a similar point or vertex in the middle. So again, like considering a very, very similar example here, if we had two rays, ST and RT, we have that our similar point is T. Let's just draw ST off like this, RT off like that. So what would we name this? The similar point is the middle point, remember? So we have STR. We could also call this RTS, RTS, STR, or we could even call it T. So that's how we would describe that angle. Sometimes you'll refer to an angle also as the following. You might call something like this theta. Okay, let's see a bit more complex of an example. We're on page 2 already. I'm so excited. So example 2. Let's say we have something that looks like this with a similar point Z, a line going up like this, X, a line coming down like here, sorry, a ray. So this is ray ZX, this is ray ZY, Let's say we have one more ray, WZ or ZW. Okay, great. So let's do this thing. Okay, so first of all, figuring out what our similar point is. So the similar point or the vertex is Z. So that'll help us figure out what our angles are. So let's do this in a few different colors. Right here, in the red, and then we'll do purple right here. And then finally orange over here. So our red similar point is Z, so we're going to stick Z right in the middle. X, Z, Y. The purple is Y, Z, W. And the orange is W, Z, X. Now, we do know something a bit more about this. So you can think about this as like one gigantic circle. So a circle, remember, has 360 degrees in it. So we can write this as a sum. So 360 degrees is equal to X, Z, Y plus angle Y, Z, W plus angle W, Z, X. Now, what if we said the following? These angles are all the same. Then we can say that 360 degrees is equal to, example, 3 times this angle, X, Z, Y, because they're all equal. So then that we get, when we divide by 3, that angle X, Z, Y is equal to angle Y, Z, W, because remember, we assume this, is equal to W, Z, X is equal to 120 degrees. So all of these angles, this one, and this one, all add up to 360, remember. Okay, so let's do another example then. Examples are the key to everything, the key to knowledge. So what if you had a triangle? ABC. So let's just consider one of the angles in here. Just consider that angle, the purple one. So our vertex is C, so we'd call this ACB, or we could also call it angle C. Now remember, the sum of the angles in a triangle is equal to 180. Okay, cool. Let's do another example. Example 4, oh my gosh. This can't get any more exciting than this. So let's have a line going up like this. Let's have a point here, ray coming off there, ray coming off there. Let's have a ray coming down. Let's have a ray going up. And what we want to do is we want to consider this red angle, this pink angle, this purple angle, and how about this orange angle? And we're going to call the points something as well. So let's call this point D, this one E. We have A rocking out here, we have B here, F, C, and G. So let's first go with the red one right here. So our vertex here, or the similar point between the two rays, is A. So we're going to have DAE. For the pink, our vertex is B. So we're going to have ABF. For the purple, our vertex is C, so we have B, C, G. Let's actually put one more point over here so we can name the other one. Let's call it H. And finally over here, C is our vertex again, so we have G, C, H. But these two are related. So what we want to call them then is, well, we need to determine what this total angle is up here. And that angle is 180 degrees, right? Because it's like a straight line. So we have that 180 degrees is equal to the angle BCG plus the angle GCH because of the straight line. Okay, so let's go to the next page. We're already on page 3. Crazy. Okay. So let's talk about some angles. So we have this situation. We have a situation that looks something like this. And then we have a situation that looks ish like that. So this is a right angle, 90 degrees. This is an acute angle, less than 90 degrees, strictly less than 90 degrees, because 90 degrees is right. And we have obtuse, which is greater than 90 degrees. Strictly greater because 90 degrees is right. So let's talk about something more. So let's say I'm going to do some more examples. So example 5. Say we had something that looked like this. Maybe something like that, okay? Where this is supposed to be a straight line. So that's equal to 180 degrees. And this angle is equal to, say, 60 degrees. Okay. So what is this angle theta then? So we know 180 degrees is equal to the sum of these two angles, 60 degrees plus theta. Can subtract by 60 and get that theta is equal to, yeah, exactly, 120 degrees. Cool. So what if we considered a bit more complex scenario? So we have a line going up like this. Pretend that's a straight ray. And we know that the angle here is given by 3x plus 2 degrees. And we know that this is 60 degrees. And this is, let's say, 2x degrees. Okay, let's do this. So again, this is a straight line. So that's equal to 180 degrees, remember? So we have 180 is equal to the sum of all this stuff. So the sum of 60 degrees plus 2x plus 3x plus 2. Subtracting the 60, we get 120 degrees is equal to 5x plus 2. Okay, so degrees. Subtracting over 2, 118 degrees is equal to 5x. And what do we have that x is equal to then? So we get x is equal to 23.6 degrees. So now we can figure out what these angles are. So we can call these angle A, B, and C. So angle A was already given in the problem that it was 60 degrees. Angle B is equal to 2x. X is 23.6 degrees. So then we know that B is equal to 47.2 degrees. Finally, C is the bit of a harder one. We have 3x plus 2 degrees, which is equal to 3 times 23.6 degrees plus 2 degrees. So it's equal to 72.8 degrees. So let's sum these up and make sure that we get what we're supposed to for the answer, which should be 180, right? So 60 plus 47.2 plus 72.8 gives us 180 like we were supposed to get. Cool. Awesome. So we got our answers for these angles. We summed them back together just to check that it gave us 180, and we got it. So yes, geometry does use algebra in what we have here. So again, hope you learned a little bit more about some angle stuff. Hope you had a fun time while doing it, and again, thanks for watching. If you have any questions, just let me know. Thanks. Have a great day, and don't forget to be awesome.